Hello there. This is the last lesson, the last new material in the constructions unit. And the last thing that we need to learn how to construct are some regular shapes that are inscribed in a circle. And I'll get to what all that means here in a little bit, but consider first this hexagon that is drawn here. Now, this is a regular hexagon, which the word regular in geometry, when it's applied to a polygon like this, it means that it's equilateral, meaning all the sides are the same measurement. And it also means at the same time that it's equiangular, meaning all of the angles are the same measurement. But it's the first one that really matters for us today. And so what that means is that this hexagon, right, all six sides are the same length. So I can mark them like that. Okay, and we need to learn how to construct it so that it's this perfect hexagon that fits right inside of a circle. So in class, we walked through this logic and everybody tried to think through it on their own, but this is the key to understanding how the construction works. So, okay, first, because these sides are congruent, okay, all of these inner angles are also congruent. So that's a really important thing to note. So the first question is, what's the measurement of this angle here, angle 1? And so the answer to that then is, if we consider that these three angles make up a linear set of angles, and we know that a linear set of angles equals 180 degrees, and there's three of them, then we could just divide 180 by 3 and we could figure out the measurement of angle 1. So angle 1 is a 60-degree angle. Alternatively, a lot of students notice that all six of these angles make a circle. And so by that same logic, you could take the entire rotation around a circle, which is 360 degrees, and divide it by 6. And again, you get 60 degrees. So angle 1 is a 60-degree angle. That's important for the thinking through this. The next thing that we did was we considered, well, this triangle here looks like it's an isosceles triangle. How do I know that it's an isosceles triangle? How do I know that these two sides are the same length? So y is, and I labeled the points here so we could talk about it, y is xy the same length as xz? And the answer to that is because remember that we're dealing with a circle. X is the center of that circle, and y and z are on the circumference of the circle. So think in your head again, what kind of line segments are those? And if you said that it's because they are both radii, they're both a radius. But so in the plural is radii. They're both radii of the same circle. That's the reason that we know that those two segments have to be congruent, right? I put the tick marks on them just so that we knew which ones we were talking about. But the reason that they're congruent is because they're both the radius of the same circle. All right, so we know that this is a 60-degree angle. We know that those are congruent. So we use this isosceles triangle theorem, which states that these two angles are also congruent because these sides are congruent. And we did a little bit of scratch work and we figured out that 180 take away 60 is 120 because the three angles add up to 180. And then we cut it in half because each of these is the same, and we got 60. All right, so all of this tells me if all three of these angles equal 60 by this logic, then that triangle is equilateral. And that is the important thing to know about this construction, is that all six of these triangles are equilateral triangles. And since two of the sides of each triangle is a radius of the circle, that means that these sides on the edges on the outside are also the same length as the radius of the circle, because all those lengths are the same. And so using the radius of the circle to find these other points is the key to the construction. Let's do it real fast. Oops. So it's over here. I made a circle, and remember that the radius of the circle, right, that length that is the radius is the same length that I'm looking for to make the hexagon, but I just need to do it along the edges, right? And there's going to be 6 points that are all evenly spaced about, and it's all going to be the same as the length of the radius. So here, I'll just use the circle tool, and I'll make a circle that has the same radius, only it's centered on this black point on the edge. And if I were to use my segment tool, for instance, and make these black intersection points like this one and this one, do you notice that kind of, if I hide this circle especially, you can kind of see that looks like, the first two sides of that hexagon. Let's look at that hexagon again. See those two sides there, right? It's kind of like that. So we know that we've kind of got three of the points, really. We just need to find 3 more points. And, finding those points is a matter of like making more circles. Here, let's make it so I'll turn that first circle back on, and you can kind of see if I just go from intersection point to intersection point, I'll make another point of intersection here and make another circle. See how each circle goes through the last points of intersection? And then I can make one here to the center, and then I can make one here to the center. And just to finish it off, I can make one there that goes to the center. And if I hide these segments I made earlier, you can kind of see that you get this neat flower shape. And this flower shape, all these circles are the same radius, right? That is the key to making this, actually lots of different shapes. I could make the hexagon like this. See, I use my polygon tool. Bam, I made the hexagon, right? It's perfect. It's perfectly inscribed. Each of these sides is the same length as the radius. But I could also make other objects that are inscribed. Like, what if I needed to make an inscribed? An inscribed means the corners are on the circumference. So I could make an inscribed, what does that look like? An equilateral triangle. It's inscribed in my original circle, which is this one here. Let's really fast. I'm going to make this circle a little bit, pop out a little bit more. I'll just make, there we go. So that the triangle is now inscribed in the circle. And, there's other things that we could do. These next shapes aren't going to be inscribed, but what if your geometry teacher asked you to construct a trapezoid? Oops, that didn't work. Anyway, you can kind of get the idea. This trapezoid is a perfect trapezoid. These two sides are parallel, and so that's a way to construct a trapezoid. Or what if you needed to construct, I don't know, how about a rhombus? A rhombus is a quadrilateral where all 4 sides are the same length. That looks like a rhombus to me, right? What if you needed to construct a parallelogram? So I could do this all day, and I won't because that would be boring. But you can use this star pattern here to construct lots of different quadrilaterals, and that's kind of where we're going to end this constructions unit, is looking at how to construct various different quadrilaterals. So go to GeoGebra and use the tutorials and try to do all of the inscribed shapes. Good luck.